Everybody, today we're going to talk about the one of the final segments, not quite the final, but one of the final segments regarding Module 1. Today we're going to talk about absolute value equations and inequalities. So I sent out some supporting document to you. It didn't have the work worked out for you. So now I'm going to include the work on the absolute value inequalities and equations. So let's do a screen share. I believe this would be it. Let's see, yep, it is. Okay, so let's take a look here. So absolute value inequalities and equations. So what is it? So we're gonna first look at equations. So it's an equation with an absolute value in it, okay? So if you want some more explanation on this, I would take a look at this link here, this video link. It's a Alta Newton video that deals with absolute value examples. Probably a good idea to take a look at that. Okay, now let's work out the examples we have. So first off, we note the absolute value of any positive number has to be positive. Absolute values are never negative. It could be zero as well. So I guess, technically it could be zero or positive. Okay, is equal to negative that number or positive that number. So for example, if the absolute value of x equaled 5, that means that the absolute that x could be minus 5 because the absolute value of minus 5 here is 5. So it makes the equation true. And it could be 5 because the absolute value of 5 is still 5. Okay, so that's all this definition says here. All right, so now if we have more than just an x inside the absolute value, and we have some things outside the absolute value as well, what we do is we first isolate the absolute value. So in this case, in B, we have the absolute value of x minus 3 plus the 6, where the 6 is outside the absolute value, equals 11. So to isolate this absolute value of x minus 3, we need to get rid of the 6. So how do we do it? We subtract it from both sides. So 6 minus 6 on this left side is 0, leaving us with just the absolute value of x. And then 11 minus 6 is 5 on the other side. So using this idea right here, taking what's inside the absolute value, saying it equal to minus the number, and plus the number, we get x minus 3 is equal to minus 5, and x minus 3 is equal to 5. So to isolate the x, which is what we would have to do, to isolate the x, we would actually add 3 to both sides in both equations. So when I add 3 to both sides in this equation, I add 3 to the minus 5, giving me x equals minus 2. When I add 3 in this equation, I add 3 and get x minus 3 plus 3 just gives me the x. Then 5 plus 3 gives me the 8. Okay, similarly in C, we have 2 times the quantity absolute value of x plus 8 minus 7 equals 9. So again, we're going to do the same process. We're going to add 7 both sides. When I add 7 to this side, it gets rid of that minus 7. When I add 7 with a 9, I get 16. So we end up with 2 times the absolute value of x plus 8 equals 16. Now to get rid of the 2, because we have to isolate the absolute value of x plus 8, we divide both sides by 2. That gives us then the absolute value of x plus 8 equals 8. Now we're going to do our process. Absolute value of x plus 8 equals minus 8, and x plus 8 equals 8. And so we will, for the x plus 8 equals minus 8, we'll subtract 8 from both sides, and that gives us x equals minus 16. In the other case, for the x plus 8 equals 8, we subtract 8 here, and we get x equals 0. And the last equation I want to look at is equation D here. In equation D, we have the absolute value of x equals minus 3. Now, an absolute value can never equal a negative number. So when I isolate the absolute value here, and on the other side I get a negative number, there's always no solution. Okay, now, that said, if I have to add or subtract some things from both sides and divide out with things on both sides, just because this is negative doesn't mean there's no solution. In other words, I could have started here with a negative 2. It's all right. because I'd still have to add the 7 and divide by 2. Okay? And then if after I do that, add the 7 and divide by 2 in question C, and it's still negative, then there's no solution. Let's look at some inequalities. So we're going to focus mainly on less thans. So the less than scenario, the absolute value of x is less than c, gets expanded into a compound inequality of minus c is less than x is less than c. Note, both inequalities are less thans. X is in the center. This number, whatever it is, negative it is on the left, and whatever this number is on the right. And if it's less than or equal, same idea, except instead of less thans, we have less than or equals. So for the absolute value of x is less than 5, we just expand it in this process, isolate the x in between, and we're done. So minus 5 is less than x is less than 5. Since the x in the center here is isolated, there's nothing else to do. That's in fact, our solution. Now, writing that in interval notation, we do not include the minus 5 or the 5. So parentheses around both, minus 5 to 5. For B, same idea. Okay. Isolate the absolute value of x minus 3 by subtracting 5, or I'm sorry, subtracting 6, and we get the absolute value of x minus 3 is less than or equal to 5. So now we're going to do our expansion. Since this number is 5, on each end we have a minus 5 on the left and a 5 on the right. And in between, in the center, we have whatever is in the absolute value. In this case, it's x minus 3. So to solve this compound inequality, we add 3 to everything. When I add 3 to the minus 5, I get the minus 2. When I add 3 to the x minus 3, I get x. And when I add 3 to the 5, I get 8. Now, since these are less than or equal to's, the minus 2 and the 8 are included. So we use brackets in our interval notation. And then for C, C is very similar to the equation C up here, at least the first few steps. We'll add the 7, divide by 2, and get the absolute value of x plus 8 instead of equals 8 is less than 8 in this case. Now we'll do our expansion. Minus 8 is less than x plus 8 is less than 8. We will subtract 8 from everything, getting minus 16 is less than x is less than 0. Since these are less thans, we have parentheses at minus 16 and 0. So it's open at minus 16 and open at 0. Let's take a look at one problem where we do a greater than. Okay, this is where we do a greater than. So in the greater than, we have the absolute value of x minus 3 is greater than 8. So when it's greater than or equal to, we expand this way. We expand as x is less than minus whatever this number is, or, can't be both at the same time, x is greater than whatever this number is. So for example, we have the absolute value of x minus 3 is greater than 8. So that means x minus 3, what's in the absolute value, is less than minus 8. That's where this comes from, right here. And we also have what's in the absolute value is greater than whatever this number is. In this case, it's 8. And we'll solve both separately. Okay, so for x minus 3 is less than minus 8, we add 3, and we get x is less than minus 5. For x minus 3 is greater than 8, we add 3, and we get x is greater than 11. So how does this work? So less than minus 5 means we go forever to the left up to minus 5, but don't include minus 5. So that means forever to the left, if we recall, is that negative infinity idea. So we can never be at negative infinity, so we have a parenthesis for open at minus infinity all the way up to minus 5 where it's open there because it's a less than. Or sometimes we use the union symbol, which is just a fancied up U, which means we combine the two. Or we start at 11 for this x is greater than 11, but we don't include 11, so we put parentheses around it, all the way to forever to the right, which is positive infinity. Since we can't get there, we put parentheses around that as well. Now, you should also take a look at this link here. This link here deals with using your graphing calculator to actually graph absolute values on your calculator. So we have one more video which deals with some some applications. And then after that, we'll take a look. I'll send out some review questions for you later in the week for your quiz. If you can do those review questions and you kept up on the homework, you're not going to have that big of a problem with the quiz. Okay? I'm not saying there isn't going to be anything on there. I don't know. Depends on the person. Some of you, no problems. Some of you might see a problem or two, well, I'm not sure of. Okay? But if you've been keeping up on things and you do the review guide and you understand the review guide, that's a big one. You have to understand it. You shouldn't have huge issues on the first quiz. All right, take care, everybody, and we'll see you next time.